led to my seeing or my interest in finding some hydrides in biology. And I thought that the best place to look for those would be in the hydrogenases. And I started thinking about that before the structures of the active sites of the hydrogenases had been established. So I first got into coordination chemistry using nickel N2S2 compounds. And all I am today, I owe to two molecules, actually. A molecule that was synthesized by Dan Mills in my research group, which has a square planar nickel and N2S2 coordination. And we were very fortunate in seeing a lot of reactivity at the sulfurs of those. Then from that, I went into the diiron hydrogenases. But we can talk more about that.
We'll get there, but let's give Don a chance to catch up. And yeah, so in terms of the threads and themes as they were established early and how they evolved to today.
Yeah, well, from the very start, I was interested in mechanistic, inorganic, organometallic chemistry. And I had this specialty in infrared spectroscopy background that was very useful at the time. And in the early 70s, because of the fuel crisis, inorganic chemists or organometallic chemists were very involved in Fischer-Tropsch type chemistry. And so the reaction I elected to investigate was the water-gas Schiff reaction, which converts some of the CO to hydrogen. And during that process, CO2 is a product of that reaction. And so for many years, we went through studying the mechanism of CO2 reactions into metal hydrides, some of which Merceda had synthesized and were well characterized. And that evolved to looking at CO2 insertion into metal carbon bonds, metal oxygen bonds, and at the same time employing in situ infrared techniques to monitor reactions at whatever conditions, high pressures, low temperatures, etc. And from there, looking at making small molecules with CO2, and eventually progressing to making polymers, which is the emphasis of our work today.
Now, this interview is unique in the sense that I have the two of you here, and while it's still not common, it's certainly more frequently encountered that scientists become life partners as well. And I think that a lot of people would be interested in how you handle that transition, how you handled moving from being a couple and locating yourself in a single position or a single place and handling all of life's other challenges at the same time that you're being professional colleagues. So let's talk about how that started, because you took a long path to get to A&M, I think.
Yeah, and certainly in those days it was not as easy as it is today. I think universities understand today that a couple is a lot more stable than a single in terms of relocating. So there's a significant amount of stability in two. But initially we traveled a pretty bumpy road. As we said, I was at Texaco, which was down the river from Vassar. I wanted academics. The place where I got a job was the State University of New York at Buffalo, which was a nice place. There were issues with the weather. Merceda was, of course, not so eager to give up her Vassar position to move to Buffalo, where she didn't have a permanent position. She had a rotating kind of position. And so it just made it difficult. But eventually, things worked out. So I think there's a lot of compromising that goes on. There's a lot of times when you're going to be separated. So it's just a question of how serious you are about making this work. I think today it's a lot easier. Universities understand it and make a real effort to accommodate couples.
Now, Marcetta, you didn't have that faculty position at Buffalo, and I know about the weather in Western New York. So what happened next?
Well, there was a point when I think it got very rocky with the marriage, and I did feel that I wasn't getting a rewarding position. So I started looking for a position of my own, and Tulane came through for me. And it wasn't so terrible because Don's parents were just up the river. So I could see them on weekends, so the connection was very strong to the Darrensburgs. And within 2 years, Tulane hired Don. So we spent our coming through the ranks years at Tulane, and I'm very grateful to them for taking the two of us. Tulane's always had a strong inorganic division and history, and we were a part of that for that time. And then Don had a sabbatical with Al Cotton, and Al decided, I think, that this would be a good hire for Texas A&M, and the two of us. And we moved together to Texas A&M.
How many years were you at Tulane, and then?
I was at Tulane for 12 years, and Don was 10.
10.
Mm-hmm. Okay.
But I think once a university like Tulane is willing to take a chance and you get tenure, then all kinds of opportunities open up because they have taken the chance to show that it works. Mm-hmm. After that, it's easy. It's an easy decision. So we were lucky.
Good. One simple question. What advice would you have? It's a simple question to ask, the answer may be long. What advice would you have for couples today starting out?
Well, somebody is going to probably have to compromise at the beginning. And that compromise may be shared. It's your turn now, it's my turn later. And we've seen that with some of our friends who are academicians. And of course, everything is different when there's children. Don and I didn't have children. We have horses and other family, but we don't have children. So but we see more and more that the stay-at-home dad or many of my students, my women students who have ambitions to be professors or high-level positions in industry, have seemingly to me chosen a partner who will be very supportive and will have a flexible job so that they may be teachers, they may be in medicine, so they can move around. So I think if you just look ahead at what the problems might be and think about it a little bit in advance, try to make the plans. But if the plans don't work and you have to take a different course, don't look back.
But I think, as Marcetta said, there is some compromising that has to be done. But what one wants to do is be realistic about the situation. Try to find places that you will both have a successful and a happy life together and a successful career. And I think I'm always reminded of what my mother told me about marriage. And that was that marriage was just a lot of compromising, and that both parties would feel they were making all the compromise. They were doing all the compromising. And of course, that's going to always be the case. But I think one advice I can give to young couples is that when they do elect to look at jobs, they should be very straightforward with their employer. I think they should let their potential employer know that there's an issue, because they typically will be interviewed one at a time. And being upfront is a lot easier for everyone than after the fact.
Let me turn to back to the science and ask you what your proudest or most important, they're not necessarily the same, proudest and most important research accomplishments. What would you identify there?
Yeah, that's a bit of a tough one, but you know, I've always sort of demonstrated the use of infrared in doing reaction mechanisms, et cetera. So I sort of developed a little bit of a reputation with using specialized equipment, et cetera, and that was always pleasing to me. But I think where I'm most pleased is when we started doing these CO2 polymerization reactions, which we took up work that was done in the early or late 60s, early 70s by Inoue in Japan. It had sort of gone along with a lot of heterogeneous catalysts that were very ineffective, and we all sort of beat our heads against the wall trying to figure out how these worked. And I got this student from Mississippi, Matt Holtkamp, who had the bright idea that why are we doing this? You know, why don't we find something new? And he came up with these very sterically bulky zinc complexes, which were homogeneous catalysts, and that really broke the field open. We published that paper in '95, and from that day on, hundreds of papers have come out in the area. So that was a very pleasing and exciting result for us.
Marcetta.
Well, when I switched from fundamental organometallic chemistry and stuck my toe in the waters of bioinorganic, this was just at the beginning of the opening of the field of hydrogenases, and a field that is very broad and has all sorts of scientists involved in it, because these hydrogenases do hydrogen chemistry just as platinum does hydrogen chemistry in fuel cells. So it would be wonderful to understand these active sites that are comprised of iron and sulfur and sometimes nickel in an elaborate molecular configuration. And we inorganic chemists, organometallic